Bismillahirrahmanirrahim. Thank you very much. Welcome again. In the previous video, we will discuss that how we can read CSV file and how we can remove discrepancy of pandas descriptive statistic by including skewness and kurtosis. Here, while doing some analysis in the previous video, here the variable was the name of variable. You can see that here is an equal sign. So just remove this equal sign and then also remove one so that we should have correct variable name and run again. Now, that most of the time, as you know that we need association between two variables. For example, we want to find covariance between two variables. So it can be variable name. Let's say linear one, then dot covariance, and you can store the value in a variable as well. And second variable, df2 say it is non-linear one. So here is the answer 15. And we can use a variable name. You can store this column data in another data frame. Let's say A. And the second one in B. So we can perform the same operation like A dot covariance and then B. Just a minute. Yes, A dot covariance and B. So here you can see that you are getting the same answer. And if we are interested to find correlation, then we can use correlation function. And it is this one, correl P in the same way. So there is a strong correlation between these two variables. We have, as you know that we have another powerful library that is NumPy library. Where first we should import that NumPy library. As NP, and we have a correlation coefficient function in this library and covariance as well. So we can use here NP dot covariance between two variables A and B. So it is showing us the covariance in matrix form. Then if you want to just get one value, then 0 row and first column. So we can apply this one, the same answer that it was in pandas data frame. We have correlation coefficient as well. In the same way, we can use this format again and just replace covariance with correlation coefficient, and it is 0.98. Now, if we want to calculate Pearson, then we can apply Pearson function. and it is available in SciPy.stats. So here we have, let's say, Spearman S dot. First we calculate, let's say, Pearson. So here we have Pearson R, and let's say between it is between two linear data set. So here we can use linear data set, and for example, first variable is df2 dot linear first, and then df2 dot linear second. And here you can see that not only it is telling us the correlation coefficient between two variables, and it is also telling us the significance as well. We can calculate Pearson, as you know that Pearson correlation is used, and it is Spearman rank correlation is used for non-linear data, and when we have outlier in the data. So we can use here S dot Spearman are, let's say, between A and B. So here is the answer, that is statistic as well as its p-value. Then we have other measures, like we have point by serial, when we want to find the association between one dichotomous variable and other continuous variable. So here we can use S dot point by serial R, and one is, let's say, dichotomous variable, and the other one is continuous variable, df2 dot continuous one. So it is it is giving us 0.44 with the p-value. And we have some other measures, like we have Kruskal. It basically measures the situation between two ordinal variables. So here I am using that measure, S dot between, because this is the between two ordinal, so I will use ordinal data set, and df2 dot ordinal 1, and then df2 dot ordinal 2. Then, for example, we have another measure that is called a Kendall correlation, and it is also used for non-normal data as well as non-linear data. So here is this measure, S dot Kendall between two variables, as I have explained. Let's say I'm using this one for simplicity. Now, all these measures are used to calculate the association amongst or between different data that is divided into, let's say, that data contains ordinal data, or the form of data is ordinal or continuous or dichotomous. Even we can calculate, or we can check the significance of the primary data. We have another test that is called a Shapiro test. Here we have the option of this one. Just a minute. SH, yes, Shapiro. Let's say we want to test the data set of A, and then we have other measure that is called KS test. And this test has two arguments. So first and then norm as well. If we have, let's say, secondary data, then we have jar beta test as well. Jar beta. So it is all about that how we can measure different measure of association by using SciPy stats library, and how we can check the normality and its significance as well. Thank you very much for watching this video.